Okay, so let's talk about volume by displacement. If I have a graduated cylinder, okay, and I fill that graduated cylinder with some water, my units here are going to be milliliters. Let's say I fill it to the 2 milliliter mark with water. This would be known as my initial volume of water. Okay, so I'm going to write this down. This is my initial volume. Okay, let's say I want to get the volume of some irregularly shaped object, like a piece of metal. When I put a piece of metal into the graduated cylinder and it's fully submerged by the water, okay, here's my little piece of metal that I'm putting in there, the volume is going to rise. So let's say it comes up to 3, okay? So my volume of water comes up to 3 milliliters. It just rises up to 3. That's known as my final volume. If I want to get the volume of the piece of metal, which is an irregularly shaped object, by displacement, we subtract. So it's the final volume minus the initial volume. You're going to want to write that down somewhere. Okay, so here 3 minus 2 would be 1, so the volume of the piece of metal would be 1 milliliter. If I'm doing student exercise number 20, it says a quartz stone has a mass of 30.475 grams. I drop it into a cylinder. The water level increases from 25 to 36.5 milliliters. So 36.5 minus 25 milliliters. We are taking the final volume minus the initial volume. And that's going to give you the volume of the quartz stone, which is 11.5 milliliters. Okay, that's volume by displacement. We use this sometimes in density. That's why it is given here in the chapter handout and described in the textbook. Okay, now if we're talking about density specifically, density is mass divided by volume. You're going to be using something called the density triangle, which looks like this. D stands for density, make a note of it. M stands for mass, V stands for volume. There are 3 different equations that you may be asked to use related to any type of density calculation, okay? So those 3 equations are density equals mass divided by volume, okay? D equals M over V. And the units for density are typically grams per milliliter or grams per centimeter cubed. Those are the most common. There may be others, but those are the most common that you'll see in this class, okay? If you're solving for mass, I should have kept my density triangle here, but I will write it back here. Before I explain solving for mass, if you're solving for density using this, just cover up the D, and it leaves you with mass divided by volume, okay? If you're solving for mass, cover up the M, and it becomes density times volume. So mass is equal to density times volume, like this, okay? Mass has units of grams, typically. Okay, if I'm solving for volume, you cover up the V, and it's going to be mass divided by density. Okay, which is this. Volume is typically going to be in milliliters or centimeters cubed, so make a note of it, okay? I got really messy there. Milliliters or centimeters cubed. That's supposed to be a parenthesis, but it really doesn't look like one. Okay, all right, now, density is a unique property of a substance. So you can identify a substance based upon its density. You don't have to memorize table 2.4. I simply gave you some densities as a reference. We're going to do a practice problem, student exercise number 21, that says, a jeweler sells a ring that is made of platinum. The ring feels a little bit light. A woman performs a test to figure out its density, because who wouldn't? We have a mass of 5.84 grams. We have a volume, water displacement of volume, which is 0.556 centimeters cubed. Is the ring made of platinum? The density of platinum is 21.4 grams per centimeters cubed. So we were given volume and mass. So that's why we can use this equation. So we're going to substitute 5.84 grams into the equation. We're going to divide it by 0.556 centimeters cubed, like this. So we got 5.84 divided by 0.556. You want 3 sig figs in your answer. This is going to end up being 10.5 grams per centimeters cubed for the density. Okay? Now, the density of platinum is 21.4. That's nowhere near the density of this ring. So that means that the ring is not made of platinum. Okay? Student exercise 22 asks you to solve for mass, mass given the volume and density. It says that you have 11.6 centimeters cubed. You should be able to identify centimeters cubed as being a unit of volume. And then you've got 19.3 grams per centimeters cubed as the density. So we're going to cover up the M. It's density times volume. And this is the equation that we're going to use. We're going to substitute the values in. It's 19.3 grams per centimeters cubed times 11.6 centimeters cubed. And it looks like this. You're going to get 223.8. We got to round it up. It's going to be 224. Centimeters cubed is going to cancel, and you're going to get grams like this. Okay? Let's go on to student exercise 23. The gasoline in an automobile gas tank has a mass of 60 grams and a density of 0.752. What is the volume in centimeters cubed? Cover up the V, use mass divided by density. So V equals mass divided by density. And you're going to put 60.0 grams on top, like this. You're going to put the 0.752 grams per centimeters cubed on the bottom. Grams is going to cancel, leaving you with centimeters cubed. So it's going to be 60 divided by 0.752. So it's 79.8 centimeters cubed. And it's like this. Okay. Okay, let's take a look at student exercise 24. Just put it right there. You're good. Thanks. The most abundant gases in our atmosphere are nitrogen, oxygen, and argon. What is the volume of 1 kilogram of air? Assume the density of air is 1.20 liters. If we want volume, we need mass divided by density. So what you're going to do is convert the 1 kilogram to grams, like this, and then you're going to get 1.00 times second E3. It's going to be 1,000 grams, so it goes up on top. The density is 1.20 grams per liter, so it's going to go like here. Okay. 1,000 divided by 1.20 is going to be 833 liters. I'm running out of room. You want 3 sig figs in your answer. Looks like this. Okay? The last one, student exercise number 25. A 1-inch cube of copper measures 2.54 centimeters on a side. What is the mass of the copper cube if the density of copper is 8.96 grams per centimeters cubed? Cover up mass, it's density times volume. You're going to use this equation. Density is 8.96. The volume, you have to calculate. You have to multiply. Since we want centimeters cubed, you've got to multiply the volume 3 times, length times width times height to get volume because you have a cube. So 2.54 centimeters times 2.54 times 2.54 is going to give you the volume, which is 16.4 centimeters cubed. Length times width times height, because I gave you the side length in centimeters. And when you multiply it 3 times, you get centimeters cubed. Centimeters cubed will cancel, giving you grams. 8.96 times 16.4. It's going to be 147 grams for the mass. Now, the density worksheet looks like this. It has 2 sides, okay? You're also going to want to watch, here's the other side. I just did all the examples in the chapter handout. But you're also going to want to watch the other density video that is posted because I placed a graduated cylinder problem on here where you order the liquids based upon density. And that problem is in the other video. And there are also some other practice problems which some students have asked for. Okay?